In this video, we don't want to continue to look at right triangles, and we want to talk about what we've already looked at, which is SOHCAHTOA. So just to refresh our memory on what we already looked at, we looked at SOHCAHTOA and sine is opposite over hypotenuse and so forth. We've already done that. We want to go take it one step further, and we want to look at, let's say we have this triangle. And if we look at it, we want to talk about how we label the triangle. And you'll notice we label our vertices as A, B, C. Those are our three angles. And then we label the sides lowercase a, our angles are uppercase, lowercase c, and lowercase b. And notice the angles, here's angle A, there's side A. Here's angle C, there's side C. Here's angle B, there's side B. So we angle the side across from the angle as a lowercase letter. And we don't always necessarily have to have C at the right angle. We can move that around. But when we look at this, we have a whole bunch of trig functions, our sine, cosine, and tangent from SOHCAHTOA that we could get from this one triangle. So let's look at angle A over here. For angle A, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Now, if we switch to angle B, that changes everything. Now B is our opposite over C. A is now our adjacent, so cosine of B is A over C. And then tangent of B is B over A. So you can see for every single triangle, we have 6 trig functions we could get from that one triangle. Now, we don't ever use angle C with SOHCAHTOA because that is the right angle. So how do we know which of these 6 to use? Well, as we do these today, that's what we want to look at. We want to pick which of these we're going to use to solve. Now, the other thing we're going to have to do today is we're going to have to try to evaluate trig values by using our calculator. So let's talk a second on how we can find sine of 70 degrees. So let me show you 2 ways. If you have a TI 8384, the first thing you want to do is you hit your mode button and you want to make sure your calculator is in degrees. Now, if you have a calculator from middle school, the TI-30, there's also a degrees button on there. If you are using this calculator, and this is just the one that's right on my computer, you want to make sure right here you're in degrees also. Now, if I want to find sine of 70, on the TI calculators, I just type in the sine of 70, and I get my answer, 0.9397. So let's write that, 0.9397. Now, if we want to do it on this kind of calculator is different. I can't do sine first. That messes it up. With this calculator, I have to do 70. Then I go click the sine button and I get my answer of 0.9397. So you can do it on any kind of calculator. You can just type sine of 70 degrees into Google and get your answer. Or tangent of 43.5 in, and we get 0.9490. So however you're going to evaluate these, 0.9490. That's what we want to do. So we want to understand how we can type this into our calculator, whatever method or calculator you're going to use, whether it be a TI, whether it be the calculator on your computer, or if you just go onto Google and type what is the sine of 70. As we do these going forward, I am going to use this TI calculator to do that. So what we want to look at today is if we are given a right triangle, we want to solve for the sides. That means we want to find what all of the sides are equal to. So as we go to solve this triangle, so we have a right triangle. We know this angle is 20. The first thing we need to do is label what we already know. This is angle C, or side angle C, so we know this is side C. This is angle A, so we know this is side A. And we know this angle, because we know those two angles add up to 90, we can take 90 minus 20 and we can get 70. So we know that this angle right here is 70. So now what we want to do is we want to try to find what is A and what is C. So I'm going to pick two trig functions to show you the difference. First, I'm going to say what is the sine of 20 is c over a. And then I'm going to say the cosine of 20 is 7 over a. Now, if you look at these two, one of these we can solve and one of these we can't. The sine of 20 we can't solve because we don't know c and we don't know a. So if you ever do a trig function and there's two variables you don't know, we can't solve that. But if I do have one variable to solve, I can solve that. So what I want to do is I want to solve this for a. Now, let me give you kind of a shortcut here as we go forward. You have two, I'm just going to make up another angle, kind of fractions you can get as you solve these. Sometimes you're going to get something that's like this, x over 5. And then sometimes you're going to have something that looks like this. Let's say 4 over x. So depending on where the variable is going to depend on how you solve. If the variable is on the bottom, all you're going to do is multiply. And x is just going to be, you take this 5 up to there, and we get 5 times cosine of 50. So if your variable's on the top and the number's on the bottom, you just multiply. If your number is on the top and the variable's on the bottom, you just switch these two things. X equals 4 over cosine of 50. This is a quick and easy way to do it. Then you can type those into your calculator. So what you have to do is see where your variable and where your number is. Number on the bottom, you just multiply. Number on the top, you switch the trig function in the x. So here, we have the variable on the bottom. So that means I just switch these two, and a is 7 divided by the cosine of 20. So now I can go to my calculator, and I can do 7 divided by cosine of 20, and I get 7.449. So that is my a. 7.449. Now at this point, I could continue to find my c by using trig functions, but now I know two sides. So I know from Pythagorean theorem that c squared plus 7 squared equals 7.449 squared. So like we've already done with Pythagorean theorem, I can come back to my calculator here, and I can square this minus 7 squared. Then I can take the square root of that to find what is c, and I get 2.548. So now I know this is 2.548. So I have solved the triangle, find all the sides and all of the angles. Therefore, I have solved the triangle. Let's do another one. So I have, this is side A, this is side B, this is 38. So I could go to my calculator and take 90 minus 38, and I get 52. So this is 52. Now, I used cosine last time. We've used sine. Let's use tangent. You can use any one of these. There's a lot of different ways you can do this. So I'm going to say tangent of 52 is a over 16. I could have used cosine of 52 is 16 over b, just like before. However, lots of different ways. We said there's 6 different ways. Now, my number's on the bottom, so I'm just going to multiply, and a is 16 times tangent of 52. I put that into the calculator, 16 tangent of 52. 16 tangent 52. And I get 20.479. Oh, and yep. So that over here is 20.479. And next to find B, I can go back to my Pythagorean theorem that we know and love so well, and go to my calculator and square that plus 16 squared. Take the square root of my answer and get 25.990. Now, one of the ways you can check these to see have you done them correctly is to just think about looking at your triangle. The smallest angle should be across from the smallest side. The largest side should be across from the right angle or the 90 degrees or the biggest angle. If I would go back, you would see smallest angle, smallest side. Biggest angle, biggest side. And that's a quick check just to see if you've messed it up or if it works out. The one other thing you'll have is we'll give you a problem like this, where we tell you the angles, but we don't have the picture drawn. So the way I would do this is to always draw a triangle. Whatever angle, you're always going to be given the right angle. So this is C. B, right anywhere you want. I'm going to put it right here. Doesn't really matter if it's to scale. That means this is A, this is side A, this is side B, and this is side C, which is 11. So right away I can see that this angle is 50. I'm going to say the sine of 40 is B over 11. It's on the bottom, so I just multiply, so I get B is 11 sine of 40. Go back to my calculator. 11 sine 40. 7.701 is my B. So I can write that over here. There's my side B. There's my angle. And then finally, we could go back to do Pythagorean theorem to find A. We have 7.71 squared plus A squared equals 11 squared. So I go back to my calculator. 11 squared minus that answer squared. Take the square root of that. 8.427. So A is 8.427. So there I have solved my triangle. I have found all of the sides and all the angles. The first few problems on your homework, you'll have a nice picture to follow. After that, you'll have to draw the picture yourself. Do not worry if it's to scale or it looks perfect. I draw every single triangle the same way, just like this one, and then label it, and then just do the math to solve it. All right, you are now ready to do the homework over right triangles, where we are solving for all of the sides.